All right, here we go. Application walkthrough. Let's get this rolling with a little bit of numerically, which again is like looking at points, usually like in a table of values. Just a different, we've been doing this, but just a different format maybe. So this just means plug -2. Which function do you plug -2 in? Well, it's a piecewise function. You have to use the top one because it is less than or equal to 0. So really, when you put -2 in, you've got to put it into the top function. And when you do that, what happens? Negative is a positive. You end up getting 6. So -2 is going to make 6 for us. 0 is kind of tricky, but which one is 0? It also goes into the top function, so plug that in there. 1 is greater than 0. It goes here. Oh no, it gets a bit tricky down here, doesn't it? Because I don't know which function does this. So what do I got to do? I got to check them both. So the first one says -12. Well, I got to check the top function. Does this make -12? And or does this make -12? Try the bottom. They both may make -12. You may have two answers here. Wow, that's tricky. Let's do the first one and see what happens. When I solve this bad boy, you know, subtract 4 from both sides. Subtract 4, -16 equals -x. So positive x, you know, divided by -1 is 16. Is that legit? In this function, can x be 16? No, x has to be less than or equal to 0. So this doesn't work, so that doesn't make it. So hopefully, when I come over here, or else Mr. Bruss wrote a bad problem, this one works. So they cancel. -3x equals -30. So divide that, that's a 30. And divide that by -3, you get 10. Is x allowed to be 10 in this case? So I'm talking about x is greater than 0 for this function. Sure, it's allowed to be 10, so it's legit. So 10 is going to make -12. Sometimes you can have two answers. They both could work. Neither of them could work. That'd be a bummer. Or one of them works. So try 9. Put 9 in both of them, see what you get. Cool, good problem. Oh, I love this one. Ms. About Sully's blood pressure and whatnot. So, can we, man, what's going on here? Oh, you're just graphing this thing. So it's a piecewise function. X stands for the time since 0. So this is like 2 hours after 8 o'clock, 3 hours after 8 o'clock, 4 hours after 8 o'clock. So that's what this means down here on the bottom. Let's see if I slide that up real quick. Get that bad boy up there. Okay, cool. So, this is like your time down here in hours after 8. So this is hours after 8 o'clock. And then this is what? Blood pressure or something? Yes, so that's his blood pressure. So I gave you a nice scale so this would work in. So let's just graph it as we read it. You could write piecewise function for this, but Sully's blood pressure starts at 90. So at 8 o'clock in the morning, he's got a 90 blood pressure. He's chilling, he just woke up, he's happy, everything's good. It rises 5 points every hour for the first 4 hours. So it goes up to 95 the first hour, then 100, then 105. We hit the first 4, and then it gets to 110. So for these first 4 hours down here, it's going up this nice linear function right here. So our domain is just 0 to 4 in this case. So this takes care of 0 to 4. Awesome. How about what's next? Well, now we're looking at, that's noon. 4 hours after 8 is noon. So from noon to 1, what happens? I'm going to change colors. He has lunch, so he's happy. He's chilling for an hour. Boom, it does that. So that's this domain right here from 4 to 5, because this 4 is after 8, so this is like 12 to 1. What I want you to do is keep this trend going. What's going to happen next? What's going to happen after that? See if you can finish this, but that's the general idea. You're making a piecewise function. Maybe use blue. We're looking at 1 to 3, which is really what? This is like saying 5 to 7. Awesome. Very cool. Keep it flowing. Good luck with that one. How about algebraically? Ooh, so I gave you the graph this time. Can you give me the pieces? Sure. There's different parts, aren't there? So the first part, let's do the easy part. The middle part is this one, right? That's a constant. So I know the middle part is 1. Y equals 1. There's the constant in there. How about this first part, though? Let's do a different color. Let's do yellow. Can I find the equation of this line here in yellow? Sure, I can find the slope. What's it doing every time? It's going up 2 over 1. So I know this is 2x. Yellow looks awful. Can I change that? That looks ridiculous. That's hard to see. So let's do it black. So y equals, it was going 2x, but what's the y-intercept? Well, I don't know, but keep it going. If I'd go up 2 over 1, aha, it would cross there at 3. So that is the first chunk. That's the black part. The purple part we know is 1. And then let's do a green part here. What is the equation of this line? So again, find the slope of that line. It's up 1 over 1, so it's 1x. What would its y-intercept be? It'd be 0. So you put plus 0, or I don't write anything. If it's plus 0, I don't need to write it. So here are my 3 parts. What are the domains for each of these? Well, the first part, let me go back. is what? It's from anything from negative infinity to negative 1. So this part is everything less than negative 1. Pretty cool. And I didn't include it because why? It's an open circle, so it's less than. How about this? What's the domain of this? Well, x is sandwiched. It's greater than negative 1, but it's less than or equal to what? Looks like positive 1. I should have used purple. It's got to flow. Got to look all the same there. All right. And then the green one, see if you can come down here. What is x? X is something. It's all the rest of them. So see if you can do that. This was supposed to help you put it together. So you make your own piecewise function there. Write it out so it looks nice. So if I gave you this, you could give me the graph. Awesome. Very nice. Verbally, we got a little word problem here. So this is the shirt that I want to make. Here are my prices. So it's kind of like the one before. You know, if I sell 0 to 20 shirts, $25 each. So if you want to make your graph over here, it's a constant. Let's say, I don't know, let's say this is counting by fives. And what are these? And you make it whatever you want. This is dollars. This is cost over here. So the y-axis I have cost. What is this in? This is t-shirts. The x is your number of t-shirts. So if x is number of t-shirts, what do you want to count by over here? I don't know, probably fives again maybe? Will that work? If not, we'll have to go back and change it, maybe 10s. 35, 40, 45, 50. Is that enough? 60. Probably not going to make more 60 shirts. Okay. So now we've got different things going on. So from 0 to 20 shirts, it's $25. So this is a constant. So when I look at it, if I make no shirts, they're still going to charge me $25. So 0 includes it. All the way out to 25 t-shirts, it's a constant. It's this price right here. What happens at 21 shirts? This is an interesting thing because it depends on what you want to do with these shirts. In real life, it's 20. Oops, did I go to 25? I went. Let's erase that. Sorry, I got a little too excited there. A little too far. Let's go back here. That should only be to 20 shirts, right? Here's 20. So the question is, what happens at 20.1 shirts or 20 and a half shirts? You can't really have a half shirt. So a couple of different ways you can handle this if you want. I'll do this one in purple, the next one here. So it drops down to $20. So if you want to just do this, I'm cool with this. It's from 20 shirts on to 30 shirts. That's pretty cool. But technically what that means is you could have 20 and a half shirts. Not going to happen. Really, there's going to be a break in your entire graph from 20 to 21. It's going to be hard for me to show that. I'm okay with this, saying that, yeah, if you made 20 and a half, I'm going to give you $20. So that's just kind of, it's okay knowing that that answer is going to happen. If either way, I'm going to count it right. So it's just good to think about. Then do this one in blue. Maybe do this one in yellow. I don't know, but you should have a cool little function there. Then see if you can write the equation. They're all going to be constants. The first one is $25. Just tell me the domain of this. When x is what? X is sandwiched between here and here. So sandwich that bad boy in there with the things. And then the next one's another constant, then another constant. All constants here. Nice flat lines, kind of cool. Kind of like a greatest integer function, step function. Pretty cool. Oh, everyone's favorite SAT prep. So hopefully you're getting the flow of these. If not, you can always try and see which ones work. The key is what? You've got between 30 and 50 inches. Which one is going to work? So really, the general format of this is what? I know what's in, if I average these two out, what's in between? It's 40 inches plus or minus 10 inches. That's key. This is like my goal. I want it to be 40 inches. I'm happy if it goes 10 inches either way. So how do you do that? Well, when you're looking at this, what are you looking for? Which part causes it to happen? So it's got to have 40 and 10 in it, I know, right off the bat. So these things with like 20, you know, this is just junk. Really, if I just look at it, man, all these are junk, aren't they? Except D. Those are the ones with the right numbers in it. But the general format of this, I don't like to give you the answers. Let me erase that. But that's how I think about it. The general format of these things is what? When I'm doing these, I'm looking at X, or whatever my variable is, minus my goal. Like, this is my target, you know? What do I want? I want the middle to be 40. Then it's less than, this is like my plus or minus. This is my tolerance over here. So this is like my plus or minus. The range, it can vary, let's say. So that's the general format. So it can vary 10 in either direction with a target of 40. All right. How about this one? This is just find the value of x plus y. So to do it, Oh, this is kind of important here too. X is less than 0, which is less than y. So what does that mean? It really means x is negative, y is positive, yeah? If that's 0, anything less than 0 is negative, anything greater is positive. So x has got to be a negative number. Why is that important? Well, because don't you get two answers here? You know, let's just solve these things. Let's solve the first one for x. I'm going to solve this for x. What I do, divide both sides by 2. I get the absolute value of x minus 9 equals 12. And then remember, you get two answers when you solve these things. You get x minus 9 equals 12, or x minus 9 equals negative 12. So that's cool, but when you get these, you get two answers, right? X is either 21 or x is negative 3 when I add 9 to both sides. But what does x have to be? X has to be the negative one. So I know the x has to be this. This is not the right answer. So once I have x is negative 3, just plug it in there. X is negative 3. Plug it in here and tell me what y is. You can probably do it in your head. Y's got to be what? Then once you get whatever y is, add negative 3 to it, grid it in over here, make sure you bubble it, and that's the SAT. Is that the last one? Boom, done and done. Good luck on the mastery check. Peace out.